Hello everyone. Test one went very well. It seems to me for most of you, almost all of you, let's say 90% of you, and hopefully the rest of the course will be also with results very well. As I noticed that some of you were struggling with the concept of classifications because it's really not really as a close concept to your everyday living. However, you will notice with association rules, and hopefully you read this chapter 6 in your blackboard, it's closer to your understanding and to your everyday living. So association rules also link it to something related to frequent item analysis or market basket analysis, which is what you do when you go to the supermarket like Walmart and you purchase a product. So actually what Walmart does, collect this data from their customers and try to analyze and see which items bought with each other, and then try to reorganize those items on the shelf accordingly. This is one reason. Second, if they see some items are purchased more than the others based on seasons, so they have to consider this and predict that to happen the following year, so they do their purchases in advance. Or the opposite, if they see some items are not purchased, so they will lower the amount of purchasing those items based on the season or the months or the holidays. So let us start with one data set. So let's open your data and the supermarket data. And as you can see in supermarket data that we have a lot of attributes. And if you go down into the list, you will see we have about 217 attributes in this data. If you want to understand the data more, as I advise most of you during the test, that open the data and try to see what is this data is all about. So if I look at this data, as you can see, I have a T, which here means transaction. There's a transaction happening, and each row here I will consider it a customer, and each column is an attribute that is related to what the customer bought. So for example, from 1 to 11, I really don't understand what the meaning of department 1, 2, 3, unless I am working for Walmart and this category has a meaning. However, in category 12, baby needs, I understand somehow what the purchase bought, and 13, bread and cake. So if we go with the rest of the data, first of all, let's see how many rows we have, and in this way we understand how many customers really bought or this data consists of. We have about 4,627, which is a big data set. So if we multiply it with 217, the number of attributes we saw, it is considered a huge data set. Let's multiply it by 200, so we will end up we having about 800,000 data and more. So it is a really big data, and that's why if you have a slow machine, will work this data slower on your machine. On the other hand, since some of those attributes are meaningless for me and for you, departments, we're going to eliminate those. We are not going to delete the data, but we are not going to consider them. So everything related to departments, I am going to select it in the time being. And you can use different tricks to eliminate those. So either you select the department, and has support, I understand what this either, or you can select the items that you are interested in. Also the total, which is the amount that the people maybe paid here. Let me leave it in the time being to understand what that means. So our goal here as association rules is to find items that are most frequently used by the customers. So I am only eliminating the department. And I'm not deleting this from the data. I'm just eliminating those attributes from the algorithms that I'm going to run on them. And as I can see, the number of departments is more than, if I look at the data better, the number of departments is bigger than the number of the other attributes. So maybe I should have did the opposite way, but it doesn't matter in the time being. We're almost done. We'll double check if we missed any department. And here's one. Okay. Seems we are fine. So what I want to do, I want to eliminate those departments. So what I'm asking for the invert. So I'm saying invert the selections that I did. So we'll take and we'll select only the attributes that are non-department. Okay. So in the time being, I want to use association rules, and the a priori was one of the one that you saw in your book. There is another one which is filtered associator, and the FPG gross or the FP gross, which is also very popular. So we'll try each one of them and we'll see which one will work the best. Also, I would like to remind you that if you click on where the algorithm is running, you can change also the attributes and the value of that algorithm. The upper bound, minimum support, and the output item set. For example, if you wanted to show, so you can select true. The value of the confidence, and which is based on it, that you want to build your measurement. You may use the lift, maybe use leverage or the convection. Those are the most popular measurements used to give you the result. What else? Also, you can read more about this attribute. Will tell you with which type of attribute it works. So for example here, and that was also available for you when we did the classification, we did mention it, but just to let you know. So this attribute works with empty nominal attributes, missing value, unary attributes, nominal attribute, and binary attribute. And so it's somehow flexible enough to find the association rules. Number of rules is 10. You may have it more. You may say I want the first 40 rules, so we'll give you more rules. So if the association rule is very difficult to find in your data, this is one way to do this. Another way is to change the lower bound minimum support and the upper bound minimum support. So maybe increase this one, decrease this one, and you will find different results. So based on the data. So let us run it first in this way, and we requested about, let's make it a little bit lower, 20 rules, and we'll see. Okay, we're gonna just start working, and as long as you see this bird moving his head left and right, okay, if you can see it, this bird, Weka, this is the name of this bird in New Zealand, Weka, that's why the application named Weka. That means the software is building a model, and as I mentioned before, this is a huge data, so it will take time until it build the model. And what kind of model we are predicting here? We are predicting to create a model that associate those items with each other. We'll say that, as you saw the very simple example in your chapter 6, maybe the first one that they mentioned about the milk and bread, that if in table 6.1, if you have a bread and milk in first, and then the second customer bought bread, diapers, and beer and eggs, etc., they found association rules. Whenever a person buys diapers, also it buys beer. So this is a very typical example in data mining in market basket analysis. So we are predicting to see something similar with this software, and it based on some kind of we use the confidence as a measurement. So based on the confidence, we'll see how many rules we can generate accordingly. Okay, so here we are. So what kind of best rules we found? So actually, before going to the rule, it worked so much. See, it was trying to find all the rules that are suitable for us. I would like you to see the measurement that has been done from the beginning. So first of all, it ran the algorithms. We had about 4,627 instances, which is we saw rows, customers in our case. We have the 217. However, some of them were eliminated. And how much size of the largest data set? Before that, the confidence was measured 0.9, the minimum support 0.1. Those are the number that you can change, so you can get different results. And it shows the number of the large items. So let us look at the rules generated here, the best rules. So what it says here, it says the following: if a customer bought biscuits and frozen food and party snack foods and fruit, vegetables, and the total was of his payment was higher than 510, most likely this is where you break your rule, which is mean this is the outcome. Most likely that if another person did the same operation but those elements or those items, will buy bread and cake, and that's for sure, and with some kind of so the total, it is high, that he paid higher amount of money. So they categorize it maybe low, medium, high, the total. They didn't mention the exact number of the payment the person paid. They did it as nominal configuration. So most likely the person will buy bread and cake. And how much you are confident that this operation will happen again? You are very, very confident, because the confidence is about 94% that this will happen. The list function equal to 1.4, the level is 0.02, is low, and those are the operations that we saw from here. If you are interested in having the other matrix, the lift, leverage, and conviction, So if you are interested of knowing those values and mapping them and getting the algorithms out of them, you can also use them. And the one that you saw at the beginning, we saw the confidence 0.9, but also we saw the support, which is this value 0.1, which is the support value, the minimum support, but usually they name it the support. Okay, and the second association rules, which is very close to the previous one: biscuits, frozen food, cheese, fruit, and with total is high, so he paid a lot of money. Also, the outcome is bread and cake. So this is another common. And the third one, the fourth one, I can see the outcome, all of them are the same. So this is what we came up with our data. And of course, when you see this kind of multiplication of the outcome, really you are not getting a lot of information. So you might consider lifting the minimum support, let's say 0.5, and let me change the rules to 10 so I can show you some kind of differences that can generate. Let's say okay, and just start again. Okay, so what we have here, the minimum support was 0.5 as we changed it, and the confidence 0.9, and these are the large item set that it was generated is the following. And the rules that was built upon this one, as you can see, best rule found 0. So it was very high. We couldn't get any rules according to this measure. So let us keep the minimum support and lower the confidence to 0.5 and see if that will work. As I said, this is data mining. You have to keep trying, changing attributes, changing rules, changing metrics until you find the best. So see here, we were able to find some of the rules, and those rules are the following. If you purchase milk and cream, you will end up of purchasing bread and cake, and the confidence was 80%, and of course the support is stable, will not change the support, and the support the one that we picked at the beginning, which is 50%. Another rule: if you buy fruit, most likely you're gonna buy bread and cake. If you buy bread and cake, you're gonna buy milk and cream. Bread and cake, you're gonna buy fruit, and those are the confidence. Of course, the first one that we run was the best one because it gave us very high. It was higher than 90%, where here the confidence is 80%. Confidence, how much confidence you have in this rule that is right or wrong. And as I can tell you, because the data set is huge, most likely when you rely on a huge data set, those results are real. So you have very high confidence. When you say 90%, it's really going to repeat in future. Let us try another type of algorithm, which is the filtered associator. And let us start. The Apriori is the most popular, and we saw the algorithm in this book. I'm trying to see if we can map, and it talks about the support threshold. This is the idea that how much the support threshold. You saw how I put the support threshold 50%, where it was at the beginning. It's starting with minimum support 10%, which is the lowest is the better. You don't want to skew your data. And as long as a bird is moving, it's creating a model. It's not easy to create a model, especially that we didn't change anything in the rules. And you can see in page 363 the FP growth algorithm, which is the most known for complex data that has a lot of trees that can be generated from, and it can prune those trees for you. So it is an alternative for the Apriori, and it can compact the data structure by using the FP3 representation. And we'll see. And here we can see very quick. If the fruit and frozen food and biscuit sounds familiar to you, I bet, and where is total actual high, most likely the bread and cake will be purchased, and with confidence 92. So it really, what it does, it ordered the rules. The number one rule is the best rule, and you notice that it was very quick because it's a pruned algorithm, as you can see from your book, how to prune the tree. The second one is similar, just the differences is here. Fruit with baking needs, biscuit, and the total was high. Bread and cake also, so you can see all of them bread and cake, and with high confidence. Let me run the first one, the Apriori, as it is actually. So you can see from here the value, the confidence 0.9, and the minimum support is 0.1. So very similar, also 92. So the result, somehow you can make a comparison between both, and I was hoping that to be able to see the tree. However, you can visualize the result. Remember that you can always maximize size and see which is based on which attribute to pick. So here only which attribute that are eliminated and which one that are considered. So really the visualization didn't help us. So mainly this is how you interpret the association rules, just by writing the rules. And you would say, like if I tell you, okay, if I have a new customer, this customer came to your store and bought frozen food and fruits and vegetables, and his payment is considered as high, what do you predict that he is buying? So you look at these rules and you will see bread and cake most likely, so you will tell me bread and cake. So I hope this idea, having this visual interface with Weka, helping you understand more the concept of association rules. And if you have any questions, please email me as soon as possible before we go more deeper in having different programs or different algorithms. Okay, good luck.